Yes, this is pre-mock examinations of Matigo. We are going to go through it. This is your teacher, Kabenge Swaib. Learners who went for a visit to a national park were amazed by the stars they saw in the dark sky at night. They had different colors and their level of brightness differed. During the day, the sky was bright and no star could be seen. They were also told that it had not rained for about 2 months, which surprised them since their school was in a wet season. One afternoon, 3 of the learners decided to go for a walk but lost their way. On calling one of the tour guides, he required them to give him an accurate location of where they were but did not know how. Using your knowledge of physics, you have different tasks down here. Task 1 says that help the learners understand why the sky kept changing. Okay, before you proceed, let us first go back to our scenario and identify how was really the color of the sky changing. Okay, we go back. Learners who went for a visit to a national park were amazed by the stars they saw in the dark sky at night. Okay, we have identified that our sky was one, dark during the night. Secondly, the sky had different colors and their level of brightness differed. Now here they are talking of how the stars during the dark sky looked like. The stars had different colors and their level of brightness differed. But to our scenario, our question here wants us to talk about how the sky was changing. We have seen the sky was dark at night too. During day, the sky was bright and at all no stars were seen. Before you answer this, let us look here critically well what really happens in order for us to answer that. We imagine we have a spherical body. This is a spherical body. And we have our source of light. This is a source of light. Probably we can use a torch. Now, when we cast light on a spherical body, we are not seeing two things. One, this sphere, when try to divide it into two parts, we are going to see a part that is dark. Secondly, a part that is bright. That is bright. Okay. Now, this part that is bright receives the light from the source, which is the torch, and the other side that is not receiving light is very dark. The same applies to when we have a star, which is our sun now, and our planet Earth. Part of this, the Earth that is lit up by the sun's light receives the daytime. Then the other end that does not receive the sun's light becomes the night. This night is characterized by darkness. Okay. Now we assume these learners during the day, that was how the sky appeared, and during the night, now the earth part of it becomes dark, meaning that it was in the dark region. Okay, now, so this one explains cause of day and what? And night. Good. Now, our second task requires us to explain why the stars had varying appearance. Now, let us go back to our scenario. How did the stars look alike? How did they vary? 1. Here they are talking of the stars they saw in the dark at night. They had different what? These stars had different colors. Secondly, their level of brightness differed. Okay, now this means that when you look at stars at night, those who have ever looked at night, this is how stars look. Like you may see star A, star B, C, D, E, and F. These stars are different in appearance in terms of color. Some stars are white, other stars are yellow, other stars are red. Secondly, stars give off light at different levels. Okay, so that is how we want to explain this. Why do these stars have different variations in terms of color and brightness? Before us proceeding, let us look at Sally and Emil. So we have two people here. We have Emil and Sally. So these two people have torches, torch A and torch B. Yes, what is the difference between torch A and torch B? When look here, torch A is bigger than torch B. Now we imagine that torch A is our star, another torch B is also another what? Another star. These two torches are different in size. Now when look at these two people, torch A is more brighter than torch B. Why? Simply because torch A is bigger than torch B. Now even stars have the same characteristic, that a bigger star is brighter than a small star. Secondly, when Emil tries to move behind, you try to see that the brightness of her torch keeps on reducing as you move behind, meaning that when we have two stars that are at different distances, we have two stars at different distances, a bigger star is at a near distance than a star that is far away. So a bigger star is more bright. So a star that is nearer the Earth is more brighter than a star which is far away from the Earth. Now we can see our sun, that is our sun, because it is the nearest star on what? On Earth. Its distance to Earth is not as much as the stars that we see during night hours. Okay, so we have stars being at different levels of brightness simply because of differences in what? In sizes of stars. Secondly, let us talk about color. Okay, we talk about colors. Okay, I've seen stars being red, white, others are yellow, others are red, others are blue. Other stars are what? Are blue. When you look at in the night sky, that is what you can observe. Now, stars are illuminated objects in the sky that are made up of plasma. Meaning that if they are illuminated, they are luminous, they give off heat. Now, the quantity of heat a star produces determines its temperature. Star A and star F have different levels of hotness. Now, stars do vary in colors simply because of their differences in what? In white stars appear hotter than red what? Red stars. So here star A is white simply because it is hotter than star what? Star F in terms of temperatures. Okay. So you can say stars appear in different colors simply because of their differences in what? In temperature. Secondly, the amount of hydrogen. So we all know that all stars produce their energy by a process of nuclear what? Nuclear fusion. This involves the reaction of hydrogen what? Hydrogen atoms. The more hydrogen a star has, the more energy is produced. This energy is in terms of what? Of heat. Now, the more heat produced, the more temperatures the star will what? Will have. So stars do appear in different colors simply because of differences in temperature and the difference in the amount of what? Hydrogen the stars have. Now our next task requires us to help the learners understand why the park they visited and their school were in different seasons. Okay, now before we attempt this, let us go back. What are these seasons that they are talking about? Okay, we begin with here. They were also told that it had not rained for about 2 months. So it not being not raining means that this was a dry spell, which is a dry season, which surprised them since their school was in a wet season. So you are going to explain why we have a dry season and we have a wet season. One of the most important factors that drives us to changes in seasons is the sun's rays that hit a given area on Earth. Okay, we all know that the Earth revolves around the sun. That is the Earth's revolution. It moves around the what? The sun on its orbit. Secondly, this Earth is tilted at a certain angle towards the what? The sun. That is, the earth is tilt. When you look critically, this earth is tilted at a given angle. This is 23.5 degrees. Now it is the earth's tilt that determines how much light is going to be falling over a given hemisphere from the what? From the sun. Now we have the northern hemisphere and the southern hemisphere. Now if the northern hemisphere is tilted, this is the northern hemisphere. If it is tilted towards the sun, we are going to expect this to experience what? Summer. Then the southern hemisphere is tilted away from the what? The sun. This region is going to experience winter. Now winter is characterized by rains. It is also characterized by coldness. Now under winter we experience shorter days than what? Than nights. Then under summer we experience heat. Why do we experience heat? Simply because of the rays that hit directly that region. Next, we experience longer nights than days. Okay, so the reason as we have a difference in seasons is simply because of the Earth's revolution around the sun, and probably that inclination or tilt of the earth on its axis that causes variations in the sun's rays that strike a given area on earth. And lastly, we have been told to help the learners determine their location. Remember, as these learners on one afternoon, they decided to take a walk, but they lost on their way. On calling one of the tour guides, he required them to give him an accurate location of where they were, but they did not know. Okay, those who have smartphones, as you try to move around, you have the GPS system on your phones. You have the GPS system. Now these learners can turn on the GPS system. This is global positioning system. It is a system that enables us to find the locations of any area where we are. So these learners can turn on the GPS system such that they can get located where they are. To sum up item 1, what were your expected responses? So you are expected to say the color of the sky kept on changing because of the rotation of the earth. When the Earth is facing the Sun, there will be daylight, hence the sky being bright. When it is facing away from the Sun, there will be no light, hence a darker sky. So that was how you are supposed to answer part A, how the sky was changing. So part B, you are meant to say stars vary in color and brightness because the variation in color is due to surface temperature. Stars appear in blue, white, yellow, and red in order of reducing hotness. The amount of hydrogen in the star stroke the edge of the star also determines its temperature. The brightness is due to the size of the star. Big stars are brighter than small stars. Stars that are near also appear brighter than those that are farther. That was our part B. Part C, you are meant to sum up and say seasons are caused by the revolution of the Earth and its inclination towards the Sun. Then areas that are inclined towards the Sun have longer days than nights, higher temperatures, and are therefore in dry seasons. Areas inclined away from the Sun have shorter days than nights, lower temperatures, and are therefore in a wet season. Then areas within the tropics have the Sun overhead, so they have two seasons, that is to say the wet season and a dry season, while those closer to the poles don't have the Sun overhead them, so they have 2 to 4 seasons, i.e. these are winter, summer, autumn, and spring. Then you are meant to say for part D, they would turn on a device with a GPS on them, e.g. a smartphone, a laptop. This device communicates with a network of resistors in the middle Earth orbit. Then we would say the satellites have atomic clocks that measure the time taken for radio waves to move from the device to the satellite. And lastly, you can also say using trilatation, the exact distance between the position of the person on Earth is determined. So that is how you are meant to, or that is how you can sum up the responses of item 1. Look at item 2. At a certain military camp, the officers were surprised when light from the Sun started dimming. At exactly 11:30 a.m., the sky became dark, which made the military officers scared. On communicating with their headquarters in another country, they were told the sky had been normal throughout that time. One of the officers offered to explain to them what led to the gradual darkness using a slide projector. He was, however, not sure if a concave or convex lens of focal length 10 placed 40 centimeters away from the slide would produce a magnification of 4, which would be big enough for everyone to see. You have been approached to help the officer prepare slides, to help the officers understand the strange phenomenon. You've been given a hint here. The sky became fully bright after 90 minutes. Use your knowledge of physics to, now these are our tasks. Task 1 tells us explain the strange phenomenon that happened. 2, help the officers understand why the people at their headquarters did not see the strange phenomenon. Help the volunteer determine if the slide projector would produce the required image. Okay, before we rush to answer this item, let us first go back to our question and we try to interpret which phenomenon that we are really talking about. At a certain military camp, the officers were surprised when light from the sun started dimming. At exactly 11:30 a.m., the sky became dark, which made the military officers scared. Okay, could they be talking about this? Let us assume that what we are seeing here down on earth is our military camp. At exactly 11:30 a.m., the sky became dark. The sky became dark gradually. Is it what they are talking about? But remember, our hint says that the sky became fully bright after 90 minutes. So as time went on, the sky became bright after 90 minutes. So that is the phenomenon that is required us to explain. Now, we have 3 bodies here that play a very big role into this phenomenon. We have up here, what we are seeing here is our sun. The next body that we see in the sky here is our moon, and on earth, it's where we find our military camp. Okay, to further understand this, we all know that the earth rotates around the sun, whereas the moon rotates around the earth, as we are seeing. That is the moon rotating around the earth. But remember, our sun is a key that contributes to most of the light on what? On our planet Earth. So that is our Earth, and the sun is a major source of what? Of light. Now, the Earth, the moon, and the sun, once they are in line, on a straight line as we are seeing here, that is a straight line, light from the sun is obstructed by the moon. That is what we are seeing. Once this phenomenon happens, some parts on earth are in total darkness, where we are seeing highlighted here, whereas other parts on earth are not in total darkness. Now, the part that is in total darkness, we say that that part is in the umbra shadow. That is the umbra shadow, where we are going to see the total darkness. Now, other parts on Earth will still receive the light, where I have highlighted here and down here. These parts will still receive the light, and that is the penumbra shadow. Now, we are going to imagine that the military camp, like we have seen earlier, the military camp was in total darkness, meaning that it was under the umbra shadow, whereas the other military camp in another country that could receive some light was in the penumbra part, because it could receive some light from the sun. So we imagine that here is where our military camp was in total darkness. Then in the other side, these sides, this is where the other military camp in another country was, so they could receive some light. And this phenomenon is what we call an eclipse. So our phenomenon here that required us to explain an eclipse. So now I think we can answer this item by explaining how an eclipse is formed, like we have seen above. Okay. Help the officers understand why the people at their headquarters did not see the strange phenomenon. Yes. So these officers from another country did not see the strange phenomenon simply because they are in a region where an eclipse did not occur. They are in a region where total darkness did not occur. All right, that is what. And lastly, help the volunteer determine if the slide projector would produce the required image. Okay, let us look back to our question and identify which image are they talking about. Now, he was, however, not sure if a concave or convex lens of focal length 10 placed 40 centimeters away from the slide would produce a magnification of 4, which would be big enough to everyone to see. So, meaning that we want to determine which of these two lenses, the concave lens and the convex lens, that will produce a magnification of 4, meaning that which of these two lenses is going to produce an image of an object which is magnified 4 times. Now, magnification, simply it is the process of making an object appear larger than its actual size. Let us choose which of these two, the concave lens and the convex lens, produces an object that is larger than its actual size. With me here, let us look at this. This is our convex lens. When you try to draw a ray diagram of it, what we are seeing here is our object. Now when you try to form an image out of it, that's a ray diagram. We are seeing that this is the image and this is our object. So image and object. So you can see that here the image is larger than the object, meaning that this is a convex, meaning that in this scenario we can say our image has been magnified, but we want a magnified image. Therefore, the best lens that we can use above for this scenario, the best lens would be suitable for use, that would be a convex lens. Since a concave lens, for it makes an object appear smaller. At any point the image, the object is, the concave lens makes it appear small, whereas a convex lens can make an object to either be magnified or it can appear diminished. Now, we want to see if our convex lens that we have chosen from a slide projector will produce the required image. Okay, now let us first identify what would really enable us to attempt the last item. We have been given that this convex lens that we have now identified has a focal length of what? Of 10. So meaning that our f, focal length f, is equal to 10 centimeters. Okay, placed 40 centimeters away from the what? The slide, meaning that the 40 centimeters is going to be our object distance from the lens. Object. Now in light, we say this is U, which is 40 centimeters. And lastly, we have been given that this lens must produce a magnification of what? Of 4. So once we see that this lens produces a magnification of 4, therefore we can now conclude by saying yes, the projector would be producing the required image. Okay, from the formula of magnification, like we said, magnification is given by two formulas. One is the image distance divided by the object distance. So you can say this is V, which V stands in for image distance, out of U. The U stands in for object distance. Or we can say that magnification is equal to image height over the object height. Okay, now meaning that we are supposed to come up with a ray diagram that is going to enable us to identify what is the image distance, what is the object distance. Then after, we shall divide the image distance by the object distance such that we can now compare our magnification. But before we draw a ray diagram, where should we place our object and where will our image be located? Okay, let us first have this. This is going to be our convex lens. Remember, earlier we had constructed the ray diagrams, so this is not new to us, that we have the F, this is the focal length, and for our case, our focal length here was 10 what? Centimeters, meaning that this 2F, we are seeing here 2F, this is our center of curvature, it is 20 what? Centimeters, since it is twice what? Twice the focal length. Now, this object distance was U, and we say that our U was 40 centimeters. Now, the ray diagram that we are going to draw is going to have our object being 40 centimeters away from the lens. That is 40 centimeters away from the lens. What happens? We are going to construct a ray diagram for that. Okay. Let us start. So I have this the F here. This is our 2F. That is object. We are seeing a ray diagram. So that is, we say these are principles that we are following. A ray that is parallel to the principal axis is reflected to pass through F. That is the focal length or the focus, the principal focus. Now, we shall have another ray that comes from the tip of an object passing through the center. So that is, now an image is going to be formed. That image is here. So you are seeing here that this image, 1, it is inverted, 2, real, and 3, it is diminished. So that is our ray diagram. Now we are going to put that ray diagram on paper. That is going to be our graph paper. So we can see that we have here, we have gotten our, this is the object. So a ray parallel to the principal axis being reflected to pass through the principal focus. This is F. Then a ray, another ray comes, and finally we have an image. Now, we are going to have, this is going to be our graph paper. We shall measure the distance, of course, from this point to this point. We say this is U, and our U is going to be 40 centimeters. Now we shall measure another distance from our lens to the object. So we can say this is V. When you try to do it on a graph paper, you find out that V will be approximately around, this is around, you can take this as 14 centimeters. Other people will come up with 15, others 13. It will depend on your level of accuracy. Then you come and say magnification is equal to Now that is going to be 14 out of 40, which is approximately 0.35. So now we have seen that our magnification is going to be 0.35. So was this image magnified really, or it was diminished? You can say now that this image was diminished. Why? Its size has now reduced. Or you can use another approach. You can use this object. First, use an object of 20. This is 20 centimeters. Now this image is around, when you try to measure here, when you try to measure this image distance, it can give you 7 centimeters. Now you can say that is 7, which is the object, the image distance, so image height, out of the what? The 20. Still, we shall come up with 0.35, which is our magnification. So you can now conclude by saying that the projector, the slide projector, will not produce the required image. The image we wanted was of a magnification of 4, but now we are seeing a magnification of 0.35. So what are the key responses that we looked at for item 2? The responses we expected the learner try to the strange phenomenon that happened was an eclipse. So you earn this mark for identification, that is I. So you earn that mark of identifying that it was an eclipse. So you earn a mark. So it was formed as a result of light from the sun being blocked. So now this is reasoning. Being blocked by the moon from reaching the what? The earth, casting its shadow. So you would expect you to get this mark of reasoning, the sun being blocked, the light from the sun being blocked, so that is R, by the moon from reaching the what? The earth, casting its what? Its shadow. Also, you also earn that mark of a shadow. So you'll also come down here and expected you to draw a diagram. So this diagram, you'd earn around 3 marks for it. A well-labeled diagram with correct rays. So that is it for part A. So part B of item 1. So the military base was in an area that can't see. So the military base was in the area, in bracket, can't see bottom or top of the sun, where the sun was in total what? Total darkness. So also earn that what? That mark. So we expected you to say the area was in total what? Total darkness, or it was not receiving what? Light from the sun. Also, the headquarters did not see the eclipse because they were in an area where the shadow did not what? Did not reach. Okay, so and lastly, you are supposed to identify which lens you are to use. So on that mark, that was a mark for identifying the lens you were to use. Okay. And lastly, we look at the mathematical bit of it. We said up there we had drawn our graph and we got our Image distance V was 16 centimeters. Then the object distance was 40 centimeters, and our magnification was V out of U. So that is 16 divided by 40. We came up with 0.4. Remember, our magnification will not have the units because the centimeters and the centimeters will disappear, or they cancel away, and we remain with no units for magnification. So you could we came down here and concluded that the slide projector would not produce the required image. Remember, the image we wanted was the of magnification 4 times, but as we got 0.4. Therefore, the projector would not produce the required image. Well, let us look at item 3. Item 3, we go through it all together. The government of Uganda plans to set up a nuclear reactor to reduce the energy cost in the country. The following ideas were fronted by one of the members of parliament. All the workers at the plant were to wear safety wear. To a detailed procedure on how radioactive materials produce electricity was to be presented, and 3, assuming 1 kilogram of radioactive material with half-life of 2 weeks is to be used. A clear time frame is required as to when a replacement will be required. A hint down here: the radioactive material will only be used to produce electricity when the mass of a material is more than 50 kilograms. Use your knowledge of physics to help provide a suitable response to the member of parliament about the raised concerns. Before we try to answer this question, let us go back, as the item requires us to provide a suitable response to the member of parliament about the raised concerns. So let us go back to our question and identify what are these concerns that the member of parliament requested. The first one that was all the members, all the workers at the plant were to wear safety wear. Now remember, we had a nuclear reactor. Now, before we try to dig deep into this concern, let us first look at what is a nuclear reactor and what is really done in the nuclear reactor. This is going to enable us find out why are really these workers requested to wear safety wear when they are at the plant. Now, a nuclear reactor is the heart of a nuclear power plant. These nuclear reactors contain and control nuclear chain reactions that produce heat through a physical process called the nuclear fission. That heat is used to make steam that spins a turbine to create electricity. So a nuclear reactor is the heart of a nuclear power plant, meaning that a nuclear power plant cannot exist without nuclear reactors. They use nuclear reactions, and that nuclear reaction used there is what we call the nuclear fission. When inside the nuclear power plant, there are a number of radiations that are emitted by the nuclear reactor. Now, these radiations are very, very, very dangerous to human life. So, as a person who really needs your life, you must save your life by wearing safety wear. Before me, I have two people. I have a person A and person B. We assume that these two people are beekeepers. This is a beekeeper A and a beekeeper B. If they have gone to harvest their honey in a beehive and bees become violent, which of these two people do you think is going to find a lot of challenges? We have person A and person B. To your own understanding, you are going to see that person B is going to find a lot of challenges. One, the face is not covered, even his hands are not what? Covered. So you expect the bees to beat this person seriously and to cause her harm, whereas person A will be safe. Why? Look at him. He is covered everywhere. Everywhere is covered. Now, we assume this is now a nuclear plant inside here. This is a nuclear plant with the radiations. And also this is another nuclear plant with also what? With the radiations. Now we say these radiations are very dangerous to human life because they cause skin irritations. So once you are not covered, these radiations are going to react with your skin and you're going to find a problem with your skin with irritations. Two, because you are inhaling these radiations, you're going to find that your body immunity is going to lower. And three, you're going to find that even they cause cancer. They can cause cancer. So these radiations in this room are very dangerous because of the above problems they cause to our bodies. As a result, you are required to put on safety wear as you are dealing with radioactive materials. Secondly, you also need to store radioactive materials in a nuclear plant. In what? In lead containers. Why? Because these radioactive materials do not penetrate through lead containers. So that is how you can also safeguard yourselves. 3, you can also hold the radioactive materials with what? pair of, now this should be computerized tongs. So that is how you can safeguard yourself against the danger of radioactive materials. So that was our first concern. So our second concern was a detailed procedure of how radioactive materials produce electricity was to be presented. Okay, remember we are looking at a nuclear reactor. We said a nuclear reactor uses what we call nuclear fission. So we're going to explain what nuclear fission is. Now, before we try to go deep, let us first have a look at this. With me, I have a nucleus, like you have seen it. It's a heavy one. As I bombard it, what I'm bombarding is a neutron. So I have a nucleus. You can say that nucleus is uranium 92 235. Now I'm going to bombard this uranium. You see, I'm actually bombarding it. What am I bombarding it with? It's a neutron. That is a neutron. Now, as a result of that bombarding, that reaction, this uranium becomes unstable. Because it has been stable, you know, when you hit something, like an egg, you can hit it with a spoon, it becomes what? Unstable. So once it becomes unstable, you expect that egg, I expect this uranium to break into further nuclei. Yes, that is what has happened. It was one previously, then bombarded with a nucleus, so with a neutron, and finally it becomes unstable, then splits into two lighter nuclei. Have nuclei A and nuclei B. So you can say the first nuclei A can be, now you can say it may form barium, that is 56 and 141, plus can say another nucleus B can be krypton 36 92. But remember, even the neutron that hit that uranium did not go anywhere. Of course, it will come out as a result. It will also split inside there because that reaction was so vigorous. So I expect some neutrons to also be as part of the results. Now what we are seeing this beyond, this is now energy. That is energy. So plus energy. Now when we try to balance this equation, we have 92 as the mass number. Then this side we have 56 plus 36, we have 92 also this side. 92 is equal to 92. Then try to balance our this is atomic mass. So atomic number 92 are equal. Then we have mass number 235 plus 1, that is 236. Then try to add this side. We have 235 actually have 230 what? 33. So we must make sure that our mass numbers balance. So you can add the 3 here. So have 3 neutrons plus 3 such that our equation now balances with 230 what? 36 on both sides. Now this is a nuclear fission. We can conclude by saying a nuclear fission is simply a reaction where a heavy stable nucleus splits is a nuclear reaction where a heavy unstable nucleus splits into 2 stable nucleus, so a nuclei with release of energy, Now, which energy is released here? This energy is heat energy. Now, once this heat is produced in a nuclear reactor, this heat is used to heat what? To heat water at a very high temperature. Now, once this water is heated, it produces steam at a very high pressure. Now, it is this that drives the turbines, which are connected to generators that convert mechanical energy into what? Into electrical what? Into electrical energy. Once we have electrical energy, it means now we can now see that we have produced what? Electricity. Okay, so that is how the second concern was. That was a report on how electricity was to be what? Produced. Concern number 3. Remember, I have to go through all the concerns. Concern number 3 required us assuming 1 kilogram of radioactive material with half life of 2 weeks. Before we answer this, let us first understand what is half-life. Half-life, simply, this is the time taken for a radioactive material to decay to half of its original mass. Now we assume that this was 1 kilogram. It was 1 kilogram. 1 kilogram is 1,000 what? 1,000 grams. It will take 2 weeks to decay to half. The half of this 1,000 is 500 what? 500 grams. But remember, our question says the hint says the radioactive material will only be used to produce electricity when the mass of the material is more than what? 50 grams. So we must make sure that we decay the 1,000 grams to a mass that is more than 50 what? 50 grams. Okay, let us proceed. From 500 grams, we shall have a half of 500 grams for another 2 weeks to be 200 what? 50 grams. So another 2 weeks, the half of 250 will be 125. So that is 2 weeks. So hope we are adding 2 weeks plus 2 weeks, that is 4 weeks, plus another 2 weeks, 6 weeks, plus still a half of 125 grams for another 2 weeks. That is 62.5 grams. Hope you're pressing your calculators. You are getting half of this, half of that, half of this, still half of that, and half of this. So these are 2 weeks plus 2 weeks, that is 4. 4 plus 2, 6. 6 plus another 2, that is what? That is 80 weeks. But remember, we must have a mass. We must decay this to a mass that is more than 50 what? 50 grams. So we can have another half of 62.5. That is, try to press my calculator here. It is giving me 31.225 what? Grams. That is for another 2 weeks. So we have exceeded. Our limit was to have a mass that is greater than what? Greater than 50 what? 50 grams. And after 10 weeks, of course, you've added from 1,000 to 31.25. We have there 10 what? We have a total of 10 weeks. A total of 10. So remember, we have been given a time frame. Which time frame is required as to when replacement will be what? Will be required. And a hint here was that mass of the reductive material should be more than 50 what? 50 grams. And after 10 weeks, the reductive material is 31.25 what? Grams. So we can now conclude by saying the replacement will be done after a time frame of what? Of 10 weeks. So item 3, you are meant to identify that these radioactive materials are what? Are dangerous. So you earn the mark of identifying that they are dangerous. So earn that mark of identification. Like our guide here, we have I. This I stands in for identifying the problem. So I've identified our problem was the radioactive materials are dangerous. So this R here stands in for reasoning. After saying that yes, they are dangerous, now how do you reason out to a person that they are dangerous? 1, they cause any skin what? Irritation. So that is your reasoning. You are now giving the dangers of radioactive materials. 2, they can cause headache. So that is another reasoning. Lower body what? Immunity. That is another reasoning. R. Cancer. Next. Okay. So these are the expected dangers of radioactive materials. The safety ways. The safety ways were such as wearing lead jackets. So now here we are identifying our safety ways. So and this mark of identifying the safety ways are now lead jackets, wearing lead jackets, wearing jackets, also that is another reasoning mark. Holding radioactive materials with computerized tongs to ensure they reduce exposure to what? To them, which exposes what? Exposes them. So also under this mark of using computerized what? Tongues. So sum up these points. A person who gave between 4 to 14 points, you earn 6 marks. Between 4 to 8 points, you earn 3 marks. Between 6 to 3 points, you earn 0 what? 0 mark. Okay. So when we look at part B, you are meant to give a detailed report on how radioactive materials produce what? Electricity. Okay, we said earlier that it is what? It's a uranium that is bombarded with what? With the neutrons. So you are meant to identify that, yes, in a nuclear reactor, we use what we call the what? The uranium that is bombarded with electrons. So you earn this mark for identifying that. Then according to the equation below, so you'd earn this mark of writing that equation. Okay. So now come down to our reasoning. The energy produced is heat what? Is heat energy. This energy we see here, so that is heat what? Heat energy, which is used to heat what? To heat water. The water produces steam at a high temperature, also under that mark. It is used to run what? To run turbines, which are connected to generators that convert mechanical energy to electrical what? Electrical energy. Okay. And lastly, our part C, we are to decay 1000 grams of radioactive material to a value that is greater than what? 50 grams. So we began with our mass of 1000, half-life, half of 1000, it is 5000. So that one takes to what? 2 weeks. From 500 we move to 250 grams for other 2 weeks, so that is 4 weeks. From 250 to 125 for other 2 weeks, that is 6 weeks. And lastly, from 125 to 62.5 for other 2 weeks, that is 8 weeks. And finally, from 62.5, half of it is 31.25, that is other 2 weeks to make 10 what? 10 weeks. So you can now come down and conclude. We concluded by after 10 what? Weeks, the mass present is 31.25. Therefore, the material replacement would be required after 10 what? After 10 weeks. Well, let us look at our next item. This is item 4. Let us go through this item. At a certain scrap yard, a metallic crowbar is used to lift heavy boxes as shown below. So in our diagram, we have this is our box and a metallic crowbar. This is it. It is used to lift the heavy boxes as shown above. The workers were surprised that lifting the box was easier when a force of 100 newtons is applied at position A than when applied at position B. What are these positions? Really, this is position, that is position A, and down here we have position B. So these are the positions that we are talking about. Okay. On a certain sunny day, they noticed that the crowbar was very hot, which made work harder to the workers. They were advised to wrap a thick woolen cloth around the crowbar to prevent their hands from being scalded. Use your knowledge of physics to, you have the first task. Explain to the workers why it was easier to lift the box when the crowbar was held at position A than position B. Part B, to help the workers understand why the crowbar burnt their hands when left in the sun. And C, explain why the wrapping crowbar with a thick woolen cloth would ease their work. Let us move to our task 1. Task A, we are required to explain to the workers why it was easier to lift the box when the crowbar was held at position what? Position A. So why is it easier for us to lift this box when this crowbar was held at position A? Okay, to clearly understand this, let us watch Mr. Sally as he tries to push a sack of maize from one position to another. This is Mr. Sally. See how he is suffering with the bag. See how he is suffering. Now, what Mr. Sally didn't know that there is a possibility of moving this bag away from that position. His intention is to keep this bag rotate. Wants to move this bag by rotating it to another position. So what Mr. Sally needed to do is to have knowledge about moment of a force. So what Mr. Sally needed to know is to apply moment of a what? Of a force. Now, moment of a force in simple definition, this is just the tendency to cause a turning effect. To cause a turning effect. Now, previously, Mr. Sally did have a force, but this force did not cause a turning what? Effect. Why? Now, we want to see why that the force did not cause a turning effect. For this moment of a force to cause a turning effect, you must have that force in place times some distance from the turning point. Distance from the turning point. But look here, what Mr. Sally did not have any distance from the turning point. The turning point is this, where he wants the load to what? To move. So what Mr. Sally did have needs to put some distance away from him. So what he did, yes, he brought a very long log of wood that he applied a force to move the what? the load. Okay, now the magnitude of moment depends on two factors. One, the force. Two, the distance. Okay, meaning that the greater the distance from the turning point, the greater the moment of what? Force, and hence the greater the turning what? The turning effect. This is similar to a person closing and opening a door from the hinges. From the what? The hinges. You realize that when you're opening the door, from the extreme end of it, you're going to find ease other than opening it just near the what? The hinges. Simply because there is a short distance from the force to the turning point, meaning that there is a less turning what? Effect. Okay. Below me here, let us watch Mr. Celestial, who has broken down. We see that is Mr. Sally. The car is now no longer moving. So what he needs to do, he has gotten in his toolbox, there are some spanners. So you have spanners A up to spanners K. So as Mr. Sally tries to use these spanners, that is the shortest spanner, trying to open the nuts of the tire. Well, it is very difficult. So you need to change his mind, tries another spanner, just started moving, okay? But still he needs to apply more force, so he had to change again his mind. Now he uses a longer spanner. We are seeing ease. There is ease. Why is there ease in opening these nuts? Simply because he has increased the distance. So the length of the spanner has increased. So an increase in distance means that there is increase in turning effect. So having seen that above, we can now go back and attempt our item. Explain to the workers why it is easier to lift the box when the crowbar was held at position A. Let us assume that this is our turning point and we have a distance from A to the turning point. We can say maybe that is 0.9 meters. And at position B, we have maybe that 0.4 meters. So we need to calculate the turning what? The turning effect, which is now the moment of what? Of a force, which is equal to the force times the perpendicular distance to the turning point. That is equivalent to, now this Mr. Star used a force of 100 what? Newtons times, now the distances, let us calculate moment at A. So that distance is 0.9 meters, which is equal to 90 Newton meters. So let us move to moment at B, which is also equal to our force. We are using the same force times that distance, 0. What? Times the distance, which is 100 times 0.4. We come up with 40 Newton meters. So when we compare the magnitude of these moments at position A and at position B, you're going to realize that the magnitude of moment at position A is greater than the magnitude of moment at position B, implying that the greater the moment, the greater the turning effect, and the less the moment of a force, the less the turning effect. So, this enables us to explain why it was easier to lift the box when the crowbar was at position A. Okay. Part B, to help the workers understand why the crowbar burnt their hands when left in the sun. To clearly understand part B, let us have a look at our animation down here. I have different metals. This is metal A, B, C, D, and E. And on them, I have gotten wax put onto the extreme ends of these metals. Then in here, I have a source of heat. Probably this is hot water. These metals have been fixed into the source of what? The source of heat. As time goes on, let us watch what happens. See? Now the wax at D has fallen. Wax at E falls faster, followed by B, C next, E, and lastly A. This shows that different materials have different rates of conductivity. Now, for good conductors, you expect that these metals will have to conduct heat what? Will have to conduct heat faster. Now assume that this was a metallic crowbar. During day, we have the sun, and down here we have gotten our metal what? Metal bar. What does the sun do? The sun now here is a major source of what? Of heat. Now that heat reaches our earth or reaches this metal bar by what? By radiation. Now what does the metal bar do? Since it is a good conductor of heat, it will absorb most of this heat that has been radiated by the what? By the sun. So the metallic bar becomes hot because it is a good conductor of heat, which is then passed through the worker's hands, hence getting scalded. Okay. And lastly, explain why wrapping the crowbar with a thick woolen cloth would ease their work. Okay, what is the role of now the thick woolen cloth? Assume that this was a hot metal bar. It is now hot. Now, when you try to get a thick woolen cloth, we try to cover it. This is woolen cloth. What is the role of this woolen cloth? Does it have the same conductivity of heat as the metal? No. Now, a wool is a poor conductor of heat. Now, if we have covered this metal bar with a poor conductor, what does the poor conductor do? It will reduce the rate of conductivity. Now, once this rate of conductivity is reduced, you'll find out that these workers' hands are going to be protected from too much heat that comes from the hot metal. So, meaning that since these woolen pieces of cloth are poor conductors of heat, the workers' hands are going to be protected against what? Against heat. To sum up item 4, okay, we said on hot days, the sun is up. When heat from the sun reaches the earth by radiation, so earn this mark of identifying that the heat from the sun reaches the earth by radiation. The crowbar radiates more of the heat. At a high rate, thereby becoming hot very quickly. So earn this mark of yes, knowing that the crowbar will radiate the heat, becoming hot very quickly. When touched, it passes on the heat to somebody's hand because it is a good It's a good conductor of heat. Okay. Then part B, we are meant to identify the best position for holding a metallic crowbar such that we find no difficulty in lifting the box. In this case, we calculate the moment of of force, which is force times the distance. Okay, the position of A from the turning point was 90 centimeters, so I had to divide 90 by 100 to get these meters. Then our turning effect would be, the force we are using was 100 newtons times 0.9 to get 90 Newton meter. So this was the turning effect of 90 Newton meter. Then for position B, it was 40 centimeters from the turning point, so I divided that with 100 to get the meters. Then we multiply the 100 times the 0.4 to get the 40 Newton meter. So we identified which position would cause a greater turning effect. That was position A. So we came down and concluded lifting the box with A was easier because the turning effect was was large. So you compare 90 with with 40. And lastly, we are meant to explain why wrapping the crowbar with thick woolen cloth would cause their work easy. Okay. Now this was our response for part C, when the cloth is an insulator. So the cloth, we are meant to identify that it is an insulator, and therefore reduces the rate of reduces the rate of conduction between the metal crowbar and the hand. This reduces the burning of the hand by by the crowbar. So that is how we summed up our item 4 for this case. Item 5, let us go through it together. The kitchen staff of a certain school are faced with challenges below. The first challenge is they need to choose between a saucepan of thickness 0.2 millimeters and another of 0.5 millimeters of the same specific heat capacity. Next, they need to agree on whether a chimney is required on the kitchen. 3. Given that a saucepan of mass 8 kilograms is used to boil 60 liters of water at 15 degrees Celsius to 100 degrees Celsius, they are required to determine the cost, the amount of money that would be required to boil the water. Down here, we have been given a hint. The specific heat capacity of water is 4,200 joules per kilogram per Kelvin. The specific heat capacity of the saucepan is 800 joules per kilogram per Kelvin. The cost per 10 kilojoules of heat provided is equal to Ugandan shillings 500. Using your knowledge of physics, you have been given the tasks below, and our task is the first one: help the staff choose which of the saucepans would enable faster cooking. Okay. Before we come up with a solution to our first item, our first task, let us go back to our scenario and identify what we should first understand before attempting our question. Okay, we have been given a saucepan of thickness 0.2 millimeters and another saucepan of 0.5 millimeters in thickness. Okay, now let us look at Madame Mary as she tries to prepare tea at home. She has, I can call this a kettle, which is made up of thickness 0.20 millimeters. That is the thickness of the base of the kettle, like down here. Then she has another saucepan with a thickness of 0.50 millimeters. So you can realize that the thickness of this saucepan is more than the thickness of the kettle. So what we shall need to do is to come up what should be the best saucepan that we should use to make cooking faster. Have you ever held a hot material with a thin cloth? What happened? What happens when you hold a hot material with a thick cloth? You will realize that a thin cloth will make you burnt faster than a thick cloth. A thick cloth will not make you burnt easily. Why? This is because heat has to travel for a longer distance in a thick cloth. So, in a thin cloth, the heat travels for a shorter distance, while in a thick cloth, the heat travels for a long what? For a longer distance. Now, the same will apply to our saucepans. We have A, which is 0.20, and B, which is 0.5 millimeters. So I expect saucepan A to be suitable for us to cook our tea faster, simply because heat will have to move for a short distance other than saucepan B, where heat travels for a longer distance. Why does this heat need to travel through the long distance in saucepan B? Simply because there are more particles that do what? That absorb the heat. Then in a thin saucepan, that is A, we have less what? Less particles that do what? That absorb the heat. So you will realize that in a thin saucepan, we shall have our tea getting ready faster. That is, the tea getting ready faster, having steam being produced faster than in saucepan what? B. So that is the challenge that we can address over that. So, in simple physics, we may say that conduction is inversely proportional to what? To thickness. Meaning that the rate of conduction increases when thickness reduces, and the rate of conduction reduces when thickness increases. So that is our item that we required to attempt. Another task is help the staff understand if a chimney is required. Remember, this is a what? This is a kitchen. Do we all know what takes place in a kitchen? A kitchen is an area where cooking takes place. Now, for us who have ever been to villages, not us who cook using a gas, you may not find what really happens in a kitchen. Before me here, you will realize what takes place in a what? In a kitchen. So imagine this is our what? This is our kitchen. This is a kitchen. What happens inside there is really terrible. That is it. You realize that in a kitchen there is a lot of smoke. Smoke is in the kitchen, more especially when firewood has not been dried. Now what happens is, in that kitchen we have air at a cooking area where there is what? Where there is fire. You find here air. That is the fireplace. Now what happens is, this air is heated. This air is heated. Once it is heated, it becomes less what? Becomes less dense. When something becomes less dense, you expect it to rise up. So even this air will have to raise what? To raise up. Now, when the kitchen has no this chimney, this is a chimney. If a kitchen has no chimney, you're going to realize that this smoke is going to stay within the what? The kitchen. So you need something that is going to drive away the what? The air out. So that is a chimney. So this kitchen needed a chimney such that that air is driven what? Out. They will have seen it being driven what? Out. And that is ventilation. It uses the principle of convection currents. That is convection. Okay, so you need a chimney to have good ventilation of the what? Of the kitchen. Okay. And lastly, help the kitchen staff determine the cost of boiling what? Water. The cost of boiling water. Remember, we said here that in our hint, the specific heat capacity of water is this. Specific capacity of the saucepan is 800. And the cost per 10 kilojoules of heat provided. So this is the gist of this question. We need to find out what is the total heat required to heat this water from 15 degrees Celsius to 100 degrees what? Celsius. But remember, these were 60 liters of what? Of heat, so of water. And this saucepan was of 80 kilograms. It was a very, very heavy saucepan. Okay, so what we need to know is the formula of heat. Heat quantity is equal to the mass of any object times the specific heat capacity of that object times the temperature change, that is change in what? In theta. Okay, now what we need to know here is to need to identify which materials or which objects are going to gain the heat. Now in our scenario, when you put your saucepan on a fireplace, this is our saucepan and this is a what? This is heat. You're going to realize that this saucepan is going to gain what? To gain heat. It will absorb some heat. Which heat is going to travel through now the what? The water inside here. Now this water will become hot. But remember, our saucepan has 80 kilograms. 8 kilograms. Now the quantity of heat that is going to be absorbed by this saucepan only will be the mass of the saucepan times its specific heat capacity times the temperature change. That is only the saucepan. Now remember, the saucepan contains what? Water. This water was 60 what? 60 liters. Now you need to convert the liters to what? To kilograms to have the same units. Now 1 kilogram is equal to 1 what? To 1 liter. Meaning that even the 60 kilograms, so the 60 liters are equal to 60 what? 60 kilograms. Now the quantity of heat that is going to be absorbed by the water will be the mass of that water times the specific heat capacity of the water times the temperature what? Change. Now remember, the heat, the initial temperatures of water and the saucepan were 15 degrees what? Celsius. Now, after heating now, the temperatures went to what? To 100 degrees Celsius. This is after heating. Temperatures will have to raise up to 100 degrees what? Celsius. What is the temperature change now? Our temperature change will be equal to, now our initial temperature was 15. Now the final temperature is 100. Now the temperature change will be 100 minus what? 15. So which is equal to 80 what? 85 degrees Celsius. Now move here to calculate our total quantity of heat. The heat provided now. Heat provided will be equal to mass of the saucepan times the specific heat capacity of the saucepan times the temperature change plus the mass of water times the specific capacity of water times the temperature change, which is equal to, now we substitute, the mass of our saucepan was 80 kilograms times the specific heat capacity of the saucepan was 100 joules per kilogram per Kelvin times the temperature change, which is 85, plus the mass of water, we say it is 60, times the specific capacity of water is 4,200 joules per kilogram times the temperature change, which is 80 what? 85. Okay. Now, when you compute this value onto our calculator, we shall have that is 54,000, that is 544,000 joules, plus when you compute this value onto our calculator, we shall have this is 214,200. There are actually 4 zeros, which is actually 21,420,000 joules. Now when we add up the total, we shall have 21,964,000 joules of what? Of heat. Now let us move to the total cost. Total cost. Now in our scenario, let us move back, we'll look at, yes, we have been told that The cost per 10 kilojoules of heat provided is Ugandan shillings 500. Now we need to first find out how many kilojoules were provided. Okay, our K is equivalent to what? To 1000. So meaning that when I get this value had calculated the total heat, we shall divide it by 1000, which is 21964,000. Divide that value by 1000. So these 3 zeros will disappear and shall have 21964 kilojoules. Now each 10 kilojoule costs 500 shillings. So we need to find out how many tens we shall have in our value. We shall divide this value by what? By still 10, which is 21964 divided by 10, such that we come up with this 2196.4. So this is 2196.4 kilojoules. Now we shall now multiply this value by 500 shillings. We shall come up with 1 million. That's 1098,200 shillings. So this is 1,098,200 shillings, and that is our final cost that we shall spend on heating the saucepan and the water provided. Let us look at our last item, that is item 6. A household with various appliances. These are the appliances. We have 2,900 watts cooker used for 3 hours daily. It has got 10 lights of 40 watts used for 8 hours daily, and a 2,900 watts water heater used for 2 hours daily is connected to a 240 volts appliances main supply. The owner was discouraged from connecting the sockets of in the series by an electrician who also emphasized the earthing of the same sockets. The owner also intends to spend 70,000 shillings on electricity weekly. You have been given a hint down here. 1 unit of electricity costs Ugandan shillings 900. Then use your knowledge of physics to, part A, explain why the electrician made the recommendations above. Part B, determine if the amount budgeted for is sufficient. Part C, identify ways of reducing the electricity bill. Before we attempt our first item, let us first go back and we searched out which recommendations did the electrician provide. Okay, the first recommendation was the owner was discouraged from connecting the sockets in what? In series by an electrician. Meaning that there is another way of connecting these electrical appliances apart from the series connection. Is there any other way? Why did the electrician discourage us from using the series connection? Let us first identify and study what really is the series connection of electrical appliances. Okay. In this animation, I want us to recognize and study what are the features of a series connection and what is a series connection. Okay. In a series connection of components, the components are connected end to end, forming a single path of current flow. As we are to watch this, in this connection, we have bulbs A. Let us label these bulbs. You have bulb A, bulb B, and bulb C. Now, when you look at these bulbs, they are connected end to end. This bulb is connected with another end of the other bulb, and also this end is also connected to this end of this bulb. We can say that this connection is a series connection. Under a series connection, we have current that is not divided. We don't have division of current. The current that flows in this bulb A is the same current that flows in that bulb B, another is the same current that flows in another bulb C. Okay. Now, let us watch what really happens when I switch on my bulbs. When the switch is on, you're going to realize that these bulbs are going to, the current flows in one direction through the whole circuit and throughout one path. There is no any other path of current. So this flow of electrons in one direction is what we call the series connection. Now, this connection has gotten its characteristics, and the main characteristics of these components are, we said there is same current flowing. Same current flowing. The second one is that the voltage at this bulb A is not the same as voltage as B, is not the same as voltage at what? At C. So there is division of what? Of voltage. Now, another characteristic of this series arrangement is that a fault in one appliance may lead to failure of other appliances from working. Now, I have got these wires. Now, you may find that when this one of these wires is put off or removed, the whole of the circuit will not work. That is what has happened. So when I removed that wire, when you remove it, you find that the whole circuit will not, all these bulbs will light, not until you bring that wire and put it back. So that is the series arrangement. Okay, now I want to look at another arrangement of electrical appliances, and that is the parallel arrangement. Okay, before us here, this is what we call the parallel arrangement of electrical appliances. We are using bulbs. We have 3 bulbs for this case. We have this bulb, 2 and 3. Now, in order for us to understand what this is, let us look at the flow of current. When you switch on the switch, we are seeing multiple paths of current. It flows through this path, that path, and another path, the last path. So under parallel arrangement of electrical components, we have these components connected side by side, providing multiple paths of what? Of current. What are the basic characteristics of this electrical circuit connection? 1, we are saying that there is multiple paths of current, showing that current is divided through these what? Electrical components. Secondly, the voltage that is under this bulb, the first bulb, the second bulb, and the third bulb, all of this voltage will be the same, unlike for series connection where we said the voltage is what? Is different. And lastly, a fault in one electrical component may not stop the working of other electrical components. Let us remove one of these wires and we see what really happens when a fault of one electrical component happens. So I'm removing this wire. Let me delete it and switch on. We are saying that when I remove this wire here, let me bring it back. When I removed this wire, yes, I saw that this last bulb did not what? Did not stop others from what? From lightening. So that is the parallel arrangement of these electrical components. So now you can compare which is the best electrical circuit that we can use at home when wiring these electrical components. They can be bulbs and other electrical components. Okay. Our next part of the question requires us to determine if the amount budgeted for is sufficient. So our budget, according to the question, was equivalent to 70,000 shillings. So this is what we have for the cost of electricity for a week. Now let us try to calculate what will be the total amount that will be required for us in running. Remember, we had the electrical appliances. We had the cooker. This cooker was rated to 2900 watts. Then it could work for 3 hours daily in a day. So I had also 10 lights. So lights, they were 10 in number, but each is rated 40 watts, and they could work for 8 hours in a day. And next we had a water heater. We had a water heater that is rated also 2900 watts and could work for only 2 hours in a day. So these were connected to a 240 volts mains supply. Okay, we are supposed to come up. How much will a cooker use in a day? How much will a light use in a day? And how much will the water heater use in a day? Okay, we know that cost of electricity is equal to number of units times the unity cost. So in our scenario, we said each unit costs 900 shillings. So let us calculate the amount we need to spend on a cooker. So let us first consider for a cooker. So let us first calculate the number of units a cooker uses in a day is equal to, shall have our power, but that power must be in kilowatt times time in what? In hours. So this time must be in hours. So our number of units will be equal to the power in units in kilowatt is, we shall have 2900. We divide that by 1000 times the time. It uses 3 hours. Okay, so this will be equivalent to, that is equivalent to 8.7 units. Okay, now the cost a cooker will take in a day will be equal to, that is 8.7 times each unit is 900, so you shall multiply that with 900 and shall come up with, that is going to be 7,830 shillings in a single day. So we can now move to lights. Let us move to lights. We had 10 lights. They were 10 in number. So the power that these bulbs will use, we shall multiply that. Each bulb was rated 40 watts, so we shall multiply that amount, that value with 10, because they are 10 bulbs. So what will be, this will be equal to 400 watts. Now it is this watts that we are going to divide with 1000. Why we divide by 1000 is to convert to kilowatt, watts. So we shall have 400 divided by 1000. So this is kilowatts. Now times the time. These bulbs would light for 8 hours in a day. That is 8 hours in a day. Then times each unit cost was 900 shillings. So we shall come up with that amount as that is, when I press my calculator, I'm getting 2,880 shillings. Okay, so we proceed to now the heater. We have a heater. Now this heater would light for 2 hours, and each heater was rated. So the heater was rated 2,900 watts. So we shall divide this with 1000 to convert to kilowatts. Then times the time, 2 hours. So this is the number of units. So times 900, which is equivalent to 5,220 shillings. So now we are going to add up this value for the heater. We also add up this value for the lights, and probably this is another value that we had for the cooker. So let us sum up. We sum up 7, so we are getting the total amount in a day. So that is 7, 8, 30. We are adding on 5, 2, 2, 0, plus another value which was 2, 8, 8, 0. Let us sum up this value. Our total shall be 15,930 shillings. So this is for a day. But remember, we are using these appliances for 7 days. So we shall multiply this value with what? 7. So that will be 7 times 15,930 shillings. And we shall come up with 111,510 shillings for a what? For a week. Now we shall compare this value with our budget. Our budget was 70,000 shillings. So that means our budget is not what? Is not enough for us to use. Okay,